And we are live. Welcome at this ElaadNL Webtalk number 38. It's the sixth one we do in the English language. My name is Erik van Kaathoven. I work as a communication manager at ElaadNL. Elaad is the Knowledge and Innovation Center on the smart and sustainable charging of electric vehicles. And we are an initiative of the joint Dutch grid operators. Today we have a special guest speaker, Gautham. He is assistant professor at the Delft University of Technology, and his presentation will be about using solar energy for charging of electric vehicles, both on board, so for example like solar cars, and off board, so for example when you have a parking lot and you add solar panels to that to charge electric vehicles. The presentation will be about 15 to 20 minutes. And after that, we have question and answers part. You can put your questions in the question box, which is part of this webinar tool, and we would welcome you to do so. Gautham will try to answer as many questions as possible. This web talk will be recorded and also available on YouTube later, probably this day. And now, without further ado, I'll give the floor to Gautham. Welcome.
Good afternoon to all of you, and thank you, Eric, for the introduction, and thank you, Elaad, for this opportunity. So, for all of you who have joined in now, what you see here are two pictures. One is a fossil fuel power plant, and the other is an electric car. So, if I ask all of you, if I take a poll now on what would you like for the future, I'm sure most of you would say, no, I would like to see the electric car in the future. I think the reasons are obvious. You have zero tailpipe emissions. The car is extremely efficient, low noise. But on the other hand, in spite of all of its benefits, there is one inconvenient truth that we have to face. And that is a fact that today we're using a lot of fossil fuel power plants to power our electric cars. So if you want to make a truly sustainable solution, how can we deal with this issue? In this graph, I tried to put together the greenhouse gas emissions and equivalent carbon dioxide in terms of grams per kilowatt hour for the electricity production in many countries in the European Union. And on the right side, I give such an example for the G20 countries. What this graph shows you is that there's a wide variation in the energy mix used for producing electricity. So on one side, you have Iceland and Sweden, which have like 0 to 10 grams of CO2 equivalent per kilowatt hour of electricity production. You have similar examples of Brazil and France, which is more small level. On the other hand, you have the other extremes where it can be 600, 700 or 900 grams per kilowatt hour. As a simple rule of thumb, if you say the efficiency of an electric vehicle is that 1 kilowatt hour will give you 5 kilometers of range, sometimes it's a bit less and sometimes it's a bit more. If you divide these numbers by 5, you can basically try to calculate how many grams of CO2 are you producing at the power plant by driving 1 kilometer with your electric car. The beauty of these graphs shows you where we could be today, and it also shows you where we could move tomorrow to a future where we can use more and more CO2-free sources of electricity production and try to make our electric vehicles completely emission-free from a well-to-wheel perspective. So that gives a motivation of the talk. How can we use solar energy as a primary source for producing electricity and using that to power electric vehicles? By doing so, you not only eliminate the emissions at the car, but you also eliminate the emissions at the power generation source as well. So zero net well-to-wheel emissions for electric mobility. The benefits of solar charging of cars are quite obvious, but I still thought it's nice to take a moment to reflect on those benefits. The first obvious benefit is a zero net emissions. The second benefit is not often looked at is the fact that both the solar panels and the electric vehicle battery are both direct current or DC by nature. Another benefit is if you look at your car's battery, I mean, typically you have now for electric cars, something in the order of 50 to 100 kilowatt hours. For trucks, you will have and buses, much larger battery packs. So the battery inside your vehicle could itself be a source of energy storage for varying PV power. So which means if you use vehicle to grid technology, by which you use a car's battery and send the energy from the battery to the grid, this will open up a new opportunity by trying to manage the variations in solar energy using the car's battery. The fourth benefit is there's an expectation that large-scale penetration of electric vehicles, I'm talking about not about 10 or 20, I'm talking about millions of electric vehicles and gigawatt of solar power into the electricity grid will cause congestions in the grid. So an interesting idea would be, can you use the solar energy and the electric vehicle charging as, instead of seeing them as two different problems, but using one as a solution for the other. This also is very interesting from a perspective of smart charging and vehicle to grid. And finally, the last benefits of solar charging is proximity. You have the benefit that you can put the solar cells on the vehicles. Here you can see solar cells sitting on the Nuna racing car from TU Delft, or you can put the solar panels on top of your office building or your home, and you can use that to charge, which means the power generation and the power consumption are very close to each other. And finally, if it's summer and if it's in the day, I can drive to work with my electric car, and while I'm working for 8 hours, I can charge from solar energy. So there's a lot of synergy that you could have between solar and electric mobility. But unfortunately, not everything is perfect about solar energy. So there is one big challenge, and the challenge is about variability in solar production. What this graph shows you is the energy yield in kilowatt hours of a 10 kilowatt solar system in the Netherlands. Of course, you can draw such a plot for different countries in the world. And what this shows you is you have dots all over the place, and you have this kind of U trend, inverted U trend. What this means is that I can produce about 80 kilowatt hours on a sunny summer day in the Netherlands, while on the other hand, there could be days in winter where the production could be close to zero. So this big variability on a day-to-day basis, because even on a summer day, you can see there is a red dot here, which is 80 kilowatt hours, but also the next red dot here, which is about 10 kilowatt hours. So even the day-to-day variation, the seasonal variation in solar is going to be a big challenge if you have to use solar as a means of charging your electric vehicles. So now that we know what are the good and the bad about charging electric vehicles and solar, let's try to focus on two topics on how you can actually realize this. So essentially, there are two strategies. The first strategy is to put the solar cells on the electric vehicle itself. And the second strategy is you can put it on the buildings or on the parking lots, and you produce the solar there, and then you transfer this energy to your car through a charging system. So let's a little bit delve into how these two compare to each other and what are the key advantages and disadvantages of the system. First, if you focus on onboard solar, there's now a new trend of putting solar cells on electric vehicles itself. Before, there were more prototypes, concept cars, student teams doing it, and you also have more conventional production level cars having it. And if you look at why should we do it, I think the two obvious answers are, first of all, there is space available on the vehicles. So in this example of the Lightyear car, you can see there's solar cells put on the front, on the top, and all the way going to the back. So there is space available, so why not use it to put solar cells on it? That's one obvious argument. And the second thing is look at the power levels and the consumption of the car. We have a lot of auxiliaries like cooling and heating and entertainment systems, which need reasonably small amounts of power, and this can be very easily fed by the onboard solar panel. This is very nice in hot countries where you have, in the afternoons, if you're driving, there's a lot of solar energy. The car also needs cooling, so you could use it, for example, use the onboard solar to cool the car. But on the other hand, you also have other disadvantages of the system. And the first issue, of course, is there's still quite a limited area on top of the vehicles. You're talking about 1 kilowatt of solar power, typically in these solar electric vehicles. And the second challenge is from shading. So you can see a typical street here with buildings and vehicles are parked. So if you're going to be parking your vehicle there, you will have shading from nearby buildings, from trees. And also, for every solar system, you have a kind of an optimal orientation. You want to face south, you want to be at a certain angle if you're the northern hemisphere. But on the other hand, on the car, because of the shape of the car, you cannot really choose very optimal angles. So that's also going to affect your solar yield. And what if your car battery is full, or you want to send the solar energy back to the grid? Currently, if you've got electric vehicles, the charger which is on the vehicle is typically unidirectional. In other words, can take energy from the grid and put inside the car. But if you have energy on the battery or on the solar on the car, you cannot take it back to the grid. So we will need bidirectional chargers going into the future. And a not so often talked about aspect of solar on the cars is about aesthetics. Maybe I like to have a red colored car or a green colored car, and because of the type of solar cells and how they're arranged, there's very limited space in terms of color choice. I'm sure there's also research going on different colors of solar cells, but if aesthetics and the look of the car is important, yeah, there is some limitations you will have by adding solar to the car on the way it looks. And finally, I think a very interesting determining factor, I don't yet have the answers for this, is what really is the economics of a 1 kilowatt PV if you have to put it on top of the car or on the roof of a building. Is it 1-to-1? I expect putting it on the car should be a bit more expensive. The question is, what is the extra cost for doing that? Now that you have a little bit of a background of how you can put solar panels on the car and what are the trade-offs, let's try to get some numbers and get a feeling of how this has been done over the years. So in order to understand how it's being done in the car, the first thing is to understand is how is the internal working of the different systems in the car. So if you have a solar electric car, you have solar panels which are connected to the DC to DC power electronics converter. So this tries to ensure that you extract maximum power from the solar panels and you match it with the voltage of the solar panels and the voltage of the EV battery. This is then connected. Sometimes you'll have an additional DC-DC stage. Sometimes this DC-DC stage does not exist. It depends on the car's architecture. And then you have a DC-AC inverter which sends this power from the battery to the electric machine of the car. And typically you have a different DC-DC converter which is used for the low voltage auxiliaries, a 12 volt or 48 volt, typically 12 volt, to send the power either from the solar or from the battery to the auxiliaries. So one of the benefits of the system is that because they're able to generate part of the energy needed using the solar on the vehicle, you will need less energy from your battery. In other words, onboard solar generation can lead to a smaller battery because you have some amount of energy being generated on the vehicle itself. And a smaller battery will also mean a lighter battery, lighter battery and a lighter vehicle, which eventually means a lower kilowatt hour per kilometer because you have a lighter vehicle because of this. So these are some of the, I wouldn't say this is a significant benefit, but this is an important benefit to be considered for solar electric vehicles. To give you some concrete examples, here you see the Vattenfall solar race car from TU Delft. The example I give here is of the 2018-19 model. This is of course not a production vehicle, but it's a kind of a student car team for the race. It's quite light. It's about 140 kg, a top speed of 130 kilometers per hour. It uses an in-wheel motor of 5 kilowatts. What is interesting is that they use very high efficiency gallium arsenide solar cells on the top of the car. And the effective area is about 2.5 meters square, and you have 30% efficient cells. These, of course, much more efficient cells than what you get from a typical crystalline silicon solar cell. Also, you have about 20 kg of battery and 5.3 kilowatt hours is how much battery is there. And you get a very high range because it's a small car, fits one person. It's very lightweight. You can get 500 kilometers of range and with an astonishing efficiency of 10 watt hour per kilometer. If you move from kind of a concept car to kind of what you would see in actual production level cars, I think a follow-up example would be the Toyota Prius PV. They came up with different concepts over the years. So I'm referring here to the one from 2017. So essentially, it took a Toyota Prius, and on the top, they put Panasonic HIT solar cells on the top. If you see the rated power of this is about 180 watts. That's the rated solar power. This means if you have the AM 1.5 light coming on, you can produce 180 watts. In reality, it's not always sunny, so you will produce a bit lower than that. And what you see here is that this was connected to the lithium-ion battery which was inside. And this would then partially provide for the power of the auxiliary. So you cannot really drive the car with this power, but you can provide part of the power needed by the vehicle through this system. Try to remember this number, 180 watts. Why? Because this car is an example where you take an existing car and you put solar cells on it, right? So in other words, you don't optimize the car's design to increase the area for solar. On the other hand, if we take an example like the Lightyear One, which is a Dutch company which makes a solar electric vehicle, here the car itself was designed bottom up to maximize the area for solar. So then what happens is that if you look at the Lightyear One, you have 1 kilowatt of solar. So in other words, 5 times more than the previous example, because of the fact that you are designing it bottom up to increase the solar surface area. And what is interesting is you have a large surface area, the solar cells are put in the front and all over the back. You can get up to 70 kilometers of solar range with this car. Just to give you some feeling for numbers, the car has a 60 kilowatt hour battery with a WLTP range of 625 kilometers. In other words, it takes about 100 watt hour per kilometer, right? So which means if you do the math for 70 kilometers, you can figure out how much energy you need, and you need to produce that much amount of energy from your onboard solar system. The Lightyear, of course, has a much higher efficiency. If you remember the earlier number I gave, 1 kilowatt hour give you 5 kilometers. That's based on the assumption that you take 200 watt hours. Of course, this is a much efficient car, so you need much lesser energy. So you always have to ask yourself, how much kilowatt peak is there? What kind of location I'm in? How much energy can I produce with that amount of solar cells on the car? And finally translate that to what is the energy consumption of the car to kind of get a feeling of what is the solar range that you will get from that particular model. Another interesting example is that of the Sono Motors car. It also has a very similar area, kilowatt of PV. It's about 1.2 kilowatts, which is again much larger than the previous example I gave, because Sono is also designed more bottom up to enhance the amount of area they have for solar. A similar battery pack of 60 for the Lightyear is about 54 kilowatt hours. Efficiency, of course, is not as high, so you have 177 watt hour per kilometer. What is interesting with the Sono is that the onboard charger inside the vehicle is bidirectional. In other words, you can produce solar energy using the solar cells on the car, store that in the battery, and use energy in the battery and feed it back to the grid. So you could have 11 kilowatts of both charging, but also discharging the car's battery back to the grid. And they're also supposed to offer vehicle to load. So what this means is that you can take this car to a remote location without a grid and still power your loads. Imagine a campsite, your laptop, lights in a remote location, using your car as a source of energy and using the solar as a source of energy in different places. I think this is a very important technology if you're going to think of solar electric vehicles. In view of time, I will not go into more examples. I want to quickly highlight that the application of solar cells on vehicles is not just restricted to car. Already, for example, in this picture, you can see the NASA Helios solar electric aircraft. This is already from 1999 to 2003, where it could lift a 900 kg payload, go at a cruising speed of 19 to 27 miles per hour, and it did a world record altitude of close to 100,000 feet. So the applications are far beyond just cars. We also have a student team in TU Delft which puts solar cells on a boat and has, so they call the solar boat team of TU Delft. And in that case, they have about 5.4 kilowatts of solar cells. You can see in this picture how the area is maximized to put the solar cells. And then it, of course, has a motor on board and a battery to basically operate the vehicle. So the applications are infinite, and I only hope that there will be more and more cases where solar cells can be integrated onto the vehicle. Moving on, the technology that you can investigate is to use charging of electric vehicles from solar, but doing it off board. In that case, the typical way to do it would be to have solar cells connected to a solar inverter and feeding power to the AC grid. And then you would have an onboard or offboard EV charger converting this AC power to DC and putting it to the car. You could use any solar inverter here and use any AC charger or a DC charger to do this. One of the interesting operations you could do is smart charging. So in this example, if you see, there is the production of wind energy as a production of solar energy, and what you can do is try to change the charging power of the electric vehicle in such a way that you follow this. So which means if there's more solar production, you control the charging to increase the charging power. So in this example, this is one of the collaborative work that we did with industrial partners. What we did at TU Delft was we use a Raspberry Pi, and what the Raspberry Pi will do is, if you look at AC charger on the control pilot, which uses a PWM based on 61851, you can adjust the pulse width of the PWM to adjust the charging current. So as the solar power changes, you adjust the PWM pulse so that you adjust the charging current. So you have the EV charging following the solar power in real time. One of the obvious disadvantages of the system that you see here is that the DC power of the solar is converted to AC, fed to the AC grid, and you again have to convert the AC power back to DC. Now, this means that you need two DC to AC power conversion stage, one in the solar inverter and to go from DC to AC and back, which is in the EV charger. And also you have power conversion losses when you go from DC to AC to back. So how do you deal with this problem of going between DC to AC? So one of the research activities we do here at TU Delft, which is also part of my PhD research, was to combine the solar inverter and EV charger into one device, fully integrated on DC. So this was part of my PhD research, and we also now follow it up with other projects at TU Delft. What we did was we developed this with our industrial partners, including PRE, which is a Dutch company. So what we have here is a kind of an integrated DC solution. So which means the solar and the EVs the power is exchanged directly on DC without any power exchange with the AC grid. What we also do is we just use a single inverter instead of two inverters that you see when you have a separate solar inverter and a separate EV charger. This, of course, makes the whole system compact and much more efficient. And what you also did was we made the inverter and the DC-DC EV charger both bidirectional. So you can take energy from the solar, store it in the EV battery, and can send the energy from the EV battery back to the electricity grid. So your car now becomes a storage for the solar. So by doing this, you can then realize 4 different power flows: PV to the car to the grid, or grid to the car. But also, if there's no electric vehicle, the whole system just operates as a solar inverter. So it's basically a solar inverter EV charger packed in a kind of a DC integration, which is much more efficient, cheaper, and more compact. Just to give a feeling of the benefits, you can see here that we use wide bandgap semiconductor devices, interleaving and powder alloy cores. And this is a typical 10 kilowatt solar inverter based on IGBT technology and also an EV charger. And this is our integrated solution, which is much more compact because of the use of the above technologies, but also because we just needed one inverter instead of two. What you see in this graph is the efficiency of our proposed system, the solid lines for different kinds of power flows compared to the dotted lines, which is what you will see in a conventional AC-based charging system, which uses silicon IGBT technology. So you can already see that it's not only more compact, it's also cheaper because you have one inverter stage less, but it's also much more efficient for different kinds of power flows. And the whole research was kind of a university industry collaboration, which means the final charger is also compatible with CHAdeMO and Combo, and is now commercially available through our industrial partners. So this brings me to the end of this talk. And the main conclusions and takeaways for all of you is solar charging is an essential technology because we can create net well-to-wheel zero emissions by doing that. We can, of course, do AC and DC charging of EV from solar, but DC is much more efficient because of the fact that the power conversion is reduced, but also you need less number of inverters. Electric vehicles and onboard solar is an emerging technology trend, which I will see more and more moving into the future. And we also developed the world's first DC solar V2G charger through our research here at TU Delft. And for all of you who want to know more about electric mobility, TU Delft has a massive open online course on electric cars, focusing on technology, business, and policy. So we have 4 courses. The courses are for free. You can access them on the EDX website, or you can go to tiny.cc/ecartlex. And you will have a lot of lecture videos, exercises, panel discussions, which cover the whole topic, right from battery technology to charging technology, how the cars works, but also having a very special focus on the business and policy aspects required for the transition to electric mobility. Thank you for your time, and I'm very eager to hear your feedback and your questions on this topic.
Thank you, Gautham. Great presentation, very interesting. And of course, still on the slide, if you want to learn more, you can find your way. So let me start with a little bit more personal question. How did you get involved with this subject? What makes it so interesting for you?
I would say, I mean, I got on the topic because I was offered a PhD position in 2013 when I was studying here in TU Delft on the whole topic of solar charging of electric vehicles. That was how I kind of entered into this topic. But to answer the question, what keeps me motivated? I mean, I really think that if you have to make electric mobility truly sustainable and emission-free, you have to target the emissions at the power plant as well. So the whole idea of solar charging makes electric mobility completely sustainable. But also, the moment you talk about solar, the immediate problem is variability. How do you deal with this variability? And the car gives you that solution because there is a battery inside that, and a battery is an expensive component. So you are not really using the solar to benefit the car, but using the car to benefit the solar. So this combination for me is like an ideal combination, which motivates me to work on this topic.
Okay, thank you. Thank you very much. So at TU Delft, what kind of project do you also do in this area of expertise?
Yeah, so I think we are on a lot of different activities, you know, kind of using this DC solar and electric vehicle integration kind of a foundation. I can give you some examples. So for example, we now have the Flexgrid and Flexinet projects. These are Dutch research projects. And what we're now doing is we're now building a system where we not only have the electric vehicle and solar charging, but we also add a stationary storage to the system. Of course, you might ask, Gautham, I mean, you already have a battery inside the car. Why do you need another one? Part of the research question is, do we really need two batteries in the first place? But also, what happens when the EV battery is, you know, not always available? How do you deal with this? Can you use the stationary storage to kind of provide that support when needed? So here we're focusing on the power electronics, but also on the energy management. And we're also trying to make this system super compact and kind of putting it underground. The reason for that is, you know, these systems are big, and you want a parking lot, for example, to be used by cars and not by these big power electronics boxes. So this is part of our ongoing research. Another example is we are now using this kind of battery PV EV charging system to focus on off-grid solar charging. So why is that important? We have to move to electric mobility all around the world, right? But you still have a lot of places which don't have access to electricity or don't have an reliable electrical grid. Then what you can do is you can use a combination of solar and a battery storage to kind of use this power to power your electric vehicles, or you could even use the electric car battery itself, a kind of a power source for your local electricity grid. So this whole focus on rural electrification off-grid will play a key role for the electrification. This is also one of our research. Another very interesting kind of a Dutch connection is we have a solar e-bike charging station. If you can come to our campus, and you can connect it. It started as kind of a master thesis topic with a bunch of students, and then we developed it further, and we finally realized it on campus. So you have 8 solar panels connected on a kind of a DC link inside, which is a 48 volts. You have you have a stationary storage, which is also connected in different kinds of electric vehicles. E-bikes and e-mopeds can be connected. Once somebody even brought an electric Twizy, you know, the little electric car, also charging from our system. And we also can do, we can demonstrate wireless charging of the e-bikes using this concept. Another part of this is how we do a project on trolley buses. I think there are a few European cities and also other cities in the world which have a trolley grid. It's like a DC grid, and we try to integrate solar onto this. So that's part of our ongoing research. And we also try to focus on the whole control aspects of solar charging through smart charging and vehicle to grid. How can you plan the charging to optimally use as much solar as possible?
Yeah. Thank you. Impressing. We look forward to hearing whatever comes out of those projects. Let me dive into some questions. Frank Udell asks, hi Gautham, very interesting. Will the slides be shared after this webinar? Are they available?
Yeah, sure. I'm very happy to share the slides. So if needed, it can be sent out to all the participants. So I'm happy to share them.
Okay, great. We'll make sure they get to everyone who wants to know. Rien van der Knaap asks, the solar range of the Lightyear is 70 kilometers. If you drive this, does that range increase on a very sunny day, or is this the maximum? This is maximum, I guess.
From what I understood from their website, but also discussions, this is seen as a kind of a upper limit. So it could be with larger area and larger more number of solar cells, but also let's say more efficient solar. This could be increased. For me, the basic rule of thumb for anybody who wants to calculate is simple. We know we have 1 kilowatt peak. Every country you can look for a number called equivalent sun hours, or ESH. In the Netherlands, it's about 2.5, I think 2.7. And if you now multiply the hours by the kilowatts, you know how much energy on average you will get, right? Of course, this number changes between the seasons. So that gives you a feeling of how much energy you can produce and therefore the range that you can get.
Yeah, and some questions about vehicle to grid and bidirectional charging, of course. Will Ernest, for example, asked, what's your opinion on this bidirectional charging, and will it be easy to adjust a home situation, for example, replacing a wall box, adding some fuses, or doing something to the fuse box, or will this be a rather big effort? What do you think?
Yeah, so I think with vehicle to grid, we have to realize there's a current technology challenge, and that is that if you look at a typical electric car, the charger which is on board is not bidirectional, right? So which means a typical EV charger is unable to take the energy from the battery back. So we need off-board DC chargers, low-power DC chargers, and that typically costs a few €1,000. So that's kind of, I would say, like a starting impediment to vehicle to grid. But we do know that new cars in the market, like the Ioniq 5, there's also a limited series with the V-Drive Solar project with the Zoe, that there's now a move towards putting bidirectional onboard chargers, also the solar motors examples that I showed. Then this impediment is gone. So then you will need the chargers with the right communication. That will be typically ISO 15118. And then, yeah, you can power your home with your electric car. Why not?
Yeah, that would be great. Is it an idea, this is a question from Simon Kopinski, is it an idea to also integrate a home battery pack when you charge on DC when the car is not available?
Yes, I think we see in our research a potential for that. So the example of the Flexgrid project or the Flexinet project I showed, where we're trying to add this extra battery to this whole charging system, is to see when the car is not available, can we use the solar power into it, or at moments where there's no grid congestion, we can charge this battery pack. And let's say you come with a car in the evening when there is an expected peak load, you could use it, discharge it. Of course, all of this will boil down to the economics of adding an extra state storage battery. But there is a lot of interesting applications of this, and also the example I gave of off-grid systems. The state storage battery could create like a kind of a backbone for an off-grid or kind of a hybrid grid-connected off-grid system as well.
Okay, thank you. So let's talk a little bit about those solar cars, like the Sono and the Lightyear. Will this probably, in your opinion, be a niche, or will this become mainstream in the near future? What do you think?
Yeah, I wish I'm really good at making predictions for the future. My feeling is this: you would expect more and more cars to have the feature of putting solar on top. I think it creates a nice green image of your electric car. Mainstream or not will boil down to the price of the car, right? If you have solar electric cars at a reasonable price point, and the price point is very relative. What is a price point? I come from India, could be very different from a price point here in the Netherlands. Then they would make it mainstream. And I think a larger question is, what is cheaper, 1 kilowatt of solar panel on the car or 1 kilowatt of solar panel on the roof? I don't know if that makes a difference, but given to me, if I see two cars I can buy for the same price, one has solar on board, the other not, I would go for the one with the solar.
Of course.
People, maybe the blue and the black color is not what they want on their car. Maybe they want a different look on their car. So maybe somebody has a difference. But I think eventually for mainstream, it's going to be price, which would be a determining factor.
Yeah. And something also a lot of people are wondering, of course, there's a lot of difference. You mentioned India, but some southern countries and countries like the Netherlands or Norway. If you look at solar panels on the roofs, people here, they have this app, and you can see what they deliver, and then you see a large seasonal effect with regard to the solar panels. So, what's your opinion on this issue?
Left to me, I will try to convince God to bring a little bit more sunshine to Norway and Dutch into the Netherlands. I'm sure the Norwegian and Dutch people are very happy about it. But now that I cannot do that, I would say every amount of sustainable energy, be it solar or wind, is currently needed, right? We need that for the energy transition. And now that you have a lot of renewable energy, the main challenge is variability, right? A variable generation needs a variable, controllable, flexible load. And I cannot think of a better load than the electric vehicle to do that, which is potential to be flexible in terms of charging, but also the potential to store the energy. So I would say, yes, it is a challenge. There's no easy solutions to deal with the seasonal variation. But on the other hand, we need all the renewables, and the EV is a perfect load for a changing renewable generation.
Yeah. Okay, so a little bit more about the DC charging. Can you explore a little bit more on the benefits of DC charging? And a question from, for example, Robert van Gent is, you mentioned the DC charger is the cheapest solution, but DC chargers are still rather expensive to buy. What is needed to bring down the costs to make them competitive with AC chargers? So,
yeah. I think that's a fair criticism as well. I think when you talk about AC chargers, it comes with the assumption that there's an onboard charger on the vehicle, right? So when you buy the car, the onboard charger comes with it. So it is indeed true that if you compare price-wise a DC charger and a solar inverter, our integrated solution will be cheaper. But if you compare an onboard charger and a solar inverter, maybe that the price comparison becomes a bit more reasonable. I do expect a trend towards more onboard V2G chargers or bidirectional chargers moving forward. So it'd be interesting dynamics between the offboard and the onboard. At the same time, the very fact that we could use one inverter, the DC to AC power conversion, for both the solar and the EV is for sure a cost saving, whether it's onboard or offboard. So that part of the cost saving will always remain. The cost saving, which is unclear, is if you buy the car, it comes with the onboard, so you get it for free, but not the offboard.
Yeah. Okay. An interesting idea from Simon Kopinski is window solar cells. Sometimes you hear about those being in development. Are those an idea to improve the total area you can put PV on a car?
Oh, that's yeah, that's a good question. I don't have an answer for it.
Okay, we'll have to look into that one and wait how technology develops. So another question is from Harm Rinks. Are charging on the car and charging while parking, are there substitutes or are they complementary? The presentation seems to suggest you have to choose between those, but perhaps you don't have to.
Yeah, I think I would see them as complementary because the power levels are a bit different. You know, if you get a feeling of the solar, you're talking about 1 kilowatt, and it's not a continuous 1 kilowatt, right? In the night, it's 0. In the afternoon on a sunny day, it's 1, and probably for the rest of the day, it's much lower. So I would think of it as a kind of a little power boost over what you can get. But the power with solar is you can kind of collect it over the whole day, so you might get a few kilowatt hours. So I see it as something which for a sunny country could give you, like, if it's giving you 70 kilometers range, yeah, that's quite reasonable amount of range for, let's say, day-to-day commute. But the bulk of the charging will need to happen through the grid.
Yeah.
But
Okay.
I think there is this notion that charging means charging the full battery. But then we know from charging behavior that people don't charge 60 kilowatt hours every single day because they don't drive that much. So if you look at actual energy use, maybe it could be comparable from an energy perspective. From a power perspective, it's very different.
Yeah, and we have to use everything we can, I guess. And in comparing, in adding a vehicle to grid, you can use everything. One of the last questions when I look at the clock is, yeah, we'll finish with this one. What will the world look like in 10 years regarding using solar energy to charge car batteries? But give us a wild guess.
And maybe I'll rephrase the question as what I would like the world to look at in the 10 years.
Okay, that's also interesting.
I think large-scale solar and wind to make renewable electricity, especially in winter and in the night. I would like to use, for example, in the Dutch context, the offshore wind to charge my electric vehicles, and then the day to use in the summer to the solar energy to do this. Our grid does have a congestion problem, and a lot of solar and wind and electric vehicles is going to be added by using not for probably for wind, but especially between solar and electric vehicles. The fact that they can be close to each other, that they can provide for each other, would be a beautiful solution by which we target both the problems by using one as a solution for the other. And I would truly love to drive with net zero emissions using electric mobility. I mean, it can't get better than that, right? With zero carbon footprint. So this is what I wish and I hope for. And I think all the essential ingredients are kind of coming together moving forward. Of course, there are challenges, but there's always challenges, and we are here to solve them.
Yeah, a rather optimistic look forward. I like that. So this was the final question we put to you. Thank you very much again for your very interesting presentation. Our next web talk will be in 2 weeks' time on the 15th of September, and it's with Christina Papadimitriou. I've started pronouncing it right, I guess. She's from the Eindhoven University of Technology, and it's about the role EVs, electric vehicles, can play in local energy communities. Also a very interesting subject, I guess. This web talk will also be in English. The one we have been doing right now will be available soon on YouTube. And thanks again, everyone. Thanks for listening and for viewing and for asking the questions. We will see you again the 25th of September, same place, same time. Thank you.
Bye-bye.